Hello everyone. I welcome you all to Startup Academy, your online gateway to get success in ISS exam. This academy is exclusively for ISS only. And we were doing in the previous lecture, we have done all the measurement of random components and the time series and all its components. In From today's lecture onwards, we'll start with advanced time series. So, what is advanced time series? So in advanced time series, till now we have learned about only the components. Now we learn how do we make use of these components or make use of other definite properties of time series for making plots and for forecasting, which is the basic objective of our time series. So for that, we first need to know some terms of the time series. Suppose we have been given a time series. The time series is T1, T2, T3 up till Tk. T1, T2, T3 till Tk. So these are the values of the time series as time 1, time 2, time t, time k, up till time k. So the first topic that we need to do is stationarity. The term speaks for itself. Stationarity means that the whenever we see a time series, then it should have constant mean, constant variance, and constant auto covariance. Auto covariance we'll do in today only. So for now, just listen about auto covariance. So if I take a time series, if we have a time series like this, suppose this is the time series. For time t, the value of t's. So here we see that con there is constant mean, as we can see. The variance is also same, and the autocovariance, one portion is equal to the next portion, is also same. So the variance, the mean, and the autocovariance when remain constant is known as the stationary time series. So the property of stationary time series are, the first property is the mean, the variance, and the autocovariance of time series remain constant. Suppose we have learned about the time series that we have here, T1, T2, T3 up till Tk. Now we have changed its time series. Suppose we are measuring the temperature of a room for 1 hour. So it is T after every 5 minutes. So it would be T5, T10, T20 up till like this. And now we have changed for 1 hour. We have calculated and taken the values, and now we have to take the new values, or we have changed the time. We are taking for the next day for the same 1 hour. So there is a shift in the time. Suppose in today's day we have taken T5 on 26th, and on 27th we have to take T5 of the same hour. Suppose this is 5 p.m. This is also 5 p.m. But this T5 and this T5 dashes, this is increasing by 1 day. So it will be 24 hours increase. So this increase or this value is known as H, or identified as H, which can be termed as lag value or integer shift, we can say. Okay, so when the joint distribution of t1, t2, t3 up till tk, and the joint distribution of t1 plus h, t2 plus h, and tk plus h are equal, then also the time series is stationary. So the second point would be the joint distribution of T1, T2 up till Tk and T1 plus H, T2 plus H up till Tk plus H are same for all H, where H is integer value. Then this is also a property of stationarity. So this we say that this is strong stationarity. Now we will talk about weak stationarity. What is meant by weak stationarity? The first point of weak stationarity is that the mean is finite and it does not depend on t. The mean is finite and does not depend on time. So this means that if the mean, suppose the mean is mu t, and it comes out to be t uh, t into something like k. K is a constant, and it comes out to be t. So whenever we'll change t, suppose we are taking mu one, so it will be k. If we are taking mu 2, it will be 2k, and so on. If we are taking mu k, it will be k square. So it is changing, as we can see that every time the mean is changing. And for stationarity, though it is weak, but for stationarity, we cannot change the values. The mean should be constant, as I have told you earlier. Otherwise, the graph would be like this if we change. Suppose for time 1, the mean was k, k, 2k, 3k up till 2k square. So for time 1 it was t1 it was k. For t2 it was 2k. For t3 it was 3k. For tk it was k square. So this is the time series, which is not where the mean is not constant, and hence we can say that it is a it is the required condition that mean should be finite and does not depend on t. The second is autocovariance depend only on the lag h. So autocovariance function depends only on lag h. It simply means that it does not depend on t. Autocovariance is represented by gamma h, gamma k, or we can say gamma h. It means covariance between xt and xt plus h. Autocovariance only depends on lag h and not on t. Okay. Now the third important point is Autocovariance is symmetric, and zeroth at lag is equals to 0, it becomes variance of xt. This we'll do in autocovariance. You just need to know this. These two are finite and constant over time. Are finite and constant over time. Finite and constant over time means does not change with time t. So these were the three properties of weakly stationary. Now we'll move forward. What is autocovariance? The third term is autocovariance. From the name itself, it suggests that autocovariance means the covariance with itself only. So I have told you one example, the temperature of the room. When I have to take the covariance between the temperature yes of yesterday's time and the temperature of today's time with the lag value h, then this covariance is termed as autocovariance. That means we are taking covariance between the same units or the same time periods, which with one lag or two lag or how many lags may be possible, but the unit is same. So autocovariance for a stationary time series, the mean autocovariance is defined as for a stationary time series having mean as estimation of xt is equals to mu t. The autocovariance, I am saying AC function, can be defined as covariance between xt and xt plus h is equals to gamma h. So this is the autocovariance function. Now if your h is equals to 0, then gamma 0 can be written as covariance of xt and x t plus 0 would be t only. So covariance of xt and xt would be nothing but variance of xt. This is one of the properties of autocovariance. If and this further can be written as estimation of x t minus mu t into xt plus h minus mu t. This can be also the formula for calculating covariance. And one more, that autocovariance is symmetric. Symmetric means the value on both sides of the zeros are same. So autocovariance of minus h is equals to autocovariance of plus h, where h can be any integer value. If I am taking minus 1, then it will be equal to plus 1, minus 2 equal to plus 2, likewise that only. Now the second term is autocorrelation function. What is autocorrelation function? Now the autocorrelation at the autocorrelation at lag h can be defined as autocorrelation is represented by rho h. So it is covariance between xt and xt plus h upon under root of variance of xt into variance of xt plus h. This is the formula for autocovariance. For and this can be further written as autocovariance as gamma h upon gamma naught. This is the formula for our autocorrelation function, where autocorrelation function is nothing but the uh, division of autocovariance at lag edge and upon autocorrelation at 0. So these were the four terms that we need to understand before moving on. I hope that you got whatever we have done today. If not, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. Revise them. These are the main concepts which will be used in advanced time series. We'll discuss more about them while doing the time series. I hope that whatever we are doing regularly, you are also doing that, because the time is less and there is a vast syllabus lying before us. So keep on working hard and keep on doing the right things at the right time. All the best. Thank you.